Okay, at time equals 0, a boiled potato, so time 0, a boiled potato is taken from a pot on a stove and left to cool. Cool is important because that means the temperature of the potato is going down. Internal temperature of the potato is 91 degrees Celsius at time equals 0. Okay, I would stop right there and write the temperature at time equals 0 is 91. The internal temperature of the potato is greater than 27 degrees Celsius for all times greater than 0. That means T at any time is always greater than 27. The internal temperature of the potato at time T minutes can be modeled by the function h. So they're going to use h instead of capital T. So I would go h of 0 is 91, and h at any time will always be greater than 27. This is a really good example of where you want to make sure you are reading the problem slow and careful, and as you read, you identify slowly and carefully key elements and get them written down. As long as I'm writing, I'm not stuck, so I can keep going. As soon as I stop writing, I'm stuck and I want to move on to the next problem. Differential equation. Okay, remember, just because they give you a differential equation doesn't mean they'll ask you to solve it. Maybe they will, but don't assume that they will. So I've got a differential equation, h, actually dh dt. So now I'm over here doing my amount and rate thing. My amount is the temperature, h of t. My rate is the differential equation, dh dt. Let's see, don't forget the negative there. Negative 1/4 h minus 27. Okay, where h is measured in degrees Celsius, we've already got that, Okay, moving on. Write an equation. Keyword, line tangent. I stop right there, I remember my picture. So, I want an equation to h. So this curve is h. Do the curve downward this time because they did say the temperature of the potato was cooling. So that's h. I'm supposed to get an equation of the line that is tangent to h. So I need this equation here. Let's see. Tangent at time equals 0. That point, the temperature of the potato is 91. This is 0, 91. All I need now is the slope right here on h. That's what this is for, to find the slope anywhere on h, just like this says right here. H finds all the points on the curve, h prime finds all the slopes on the curve. This equation is essentially h prime. So I'm going to write down, for the grader to see, dh over dt at 0, 91 is going to equal negative 1/4, parenthesis, 91 subtract 27. And I really don't have to go further than that. I can just stop with that. That's my slope of the line tangent. I don't want to make a mistake. I could grab my calculator and work it out. In fact, don't really like writing all that again. So let's see, 91 minus 30 would be 61. 61 plus 3 is 64. 64 divided by 4 is 16. So this is negative 16. And again, I could use my calculator to do that, or I could just leave it as one big expression Don't really have to write it in a simpler way. So now I write the equation of the line tangent is going to be y equals negative 16 t minus 0 plus 91. That's my equation of the line tangent. So that got me to here. They give me 2 points for that. 1 point for finding the correct slope, and another point for putting it in the tangent line equation formula. Use this equation to approximate the internal temperature of the potato at time equal 3. So that's essentially like saying we come over here where time is equal to 3. Oh, wrong button. So come over here where time is equal to 3. Let's write that down. So right here, hitting the wrong button. So let's see, here we go. That point and this point. And so we're right here. So those 2 points are at t equal 3. The green dot, the green, is really the point 3 comma h of 3. We're trying to approximate that. We're going to do it with the purple dot, because the purple dot is what we find using this equation right here. Because remember, the tangent line equation finds all points that are on the tangent line. So I write h of 3 can be approximately calculated using negative 16, plug in 3 for the time, and that's it. It is degrees Celsius. They did not say I had to use the units, so they won't take off any points if you don't put the units. But as long as you have that equation for approximating the temperature, you'll get 1 more point for a total of 3 points on this part A.